Alright, Algebra. This is section 6 and 7 from chapter 1. We're going to first review some terms that you should have covered last year. An ordered pair, it looks like this. It's an X and a Y. It's usually a location on a coordinate plane representing a point. A relation is a set of ordered pairs. So if something is a set, we put those in squiggly brackets, a set of ordered pairs. So let's say 1, 2, 3, 4, 7, 9, just to make it not so obvious. Just a set of ordered pairs. In a set, all of the X values are called your domain. The X values in a relation. Again, a relation was a set of ordered pairs. So the Y values make up the range. Now, I like to give my students a way of remembering when you're graphing, ladies always go first. So let's turn our X into a lady. And then the gentleman will go second after the lady. So when you're graphing on a plane, on a graph. Also, a female deer is called a doe. A deer, a female deer. So maybe to help you remember the domain or your X values, I always like to give that little mnemonic to try to help keep those straight. Alright, so section 6 is review, and section 7 starts talking about this word functions. Here is a machine. When you put a number into this machine, it spits out a new number. For this particular box, it's going to spit out a 2 when you input 0. So if I plug in 0 here on this side, it's going to spit out a 2. So when I put in 0, I get out 2. If I put in 5, so we could erase this and put in 5, it spits out a 7. So 5, 7. Okay, these are ordered pairs. We call what the box is doing a function. It is a relationship between the input and the output. For every input, there is one and only one output. So to be a function, for every X, this is your X, and this is your Y. For every X, there can only be one Y. If there's more than one Y with an X, it is not a function. Usually, the input is called the independent variable. It's very independent. You can put in anything you want. But the output is a dependent variable because it depends on what you put in. Okay, so the input is independent. The output depends on the input. Therefore, it's a dependent variable. It depends. Alright, so what do you think the relationship is in our box here at the beginning? For everything we put in 0, we got out 2. We put in 5, we get out 7. I think that whatever you put in for X, you add 2. That would be our function. Alright, so in that case, if you input a 2, you should get out a what? I hope you said it, 4, because we're adding 2 each time. Okay, so I want to go back up here and I want to call this machine is our function machine. Alright, and our input, we're putting in our what? Our X. This was also our domain. So you're going to put in your dough, and it's going to go into the function machine, and it's going to do its thing, and then it's going to spit out the range. And to help you remember that the part that gets spit out, I like to turn my range into an orange. Maybe it's a Coke machine. You put in the dough into your Coke machine, and it spits out maybe like an orange soda. Okay, I'm not very good at drawing orange soda, but you can make it an orange crushed soda, whatever you need to do to help you remember that you put in your dough and it spits out the range. Alright, so that's your function machine. We could represent the function by graphing the inputs and outputs using a coordinate plane. That's where those ordered pairs come in. The x-axis represents the input. Again, the domain, the lady, is your x, and the y-axis represents the output. To graph the function, we draw points or ordered pairs like 0, -2. I think this is a typo. I think this is supposed to be 0, 2, because the next sentence says to place the first 2 points from our function. Our first point was 0, 2, so I think that was a typo. Okay, so we're going to practice graphing on the xy coordinate plane. So we have 0, 2. If we go back up, I believe our next number was 5 and 7, and then they asked us if we put in a 2, what is the machine going to spit out? And it's going to spit out a 4. So let's plot these points. So here we go. We start at the origin, 0, 0, that's the beginning point, and we travel, x travels 0, and y went up 2. So there's our first point, 0 for x and 2 for y. So ladies first, the x coordinate goes first. So now we're going to go 5, 7. I think my chart here is going to be a little bit small. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I'm going to estimate where 7 would be. 2, 4. 1, 2. Up 4. 1, 2, 3, 4. Okay, so there are those 3 points. Then it says, where might other points of this function be? Well, let's put in a negative number. I'm just curious. If I put in -2, because we said that what is happening here, it's x plus 2. So -2 plus 2 is going to give me 0. So if I travel on the x-axis to -2, I go nowhere on the y-axis. What if I put in 1/2? I can put in all kinds of decimals. I can put anything in I want to for x. Well, 1/2 plus 2 is going to give us 2.5. So if I put in, for my x I only went half, then I'm going to travel up 1, 2.5, and it's going to be right there. So I'm noticing that all these points seem to be lining up. Alright, so could they be anywhere else? So besides the 2 points that I've chosen here, could points be anywhere else? And yes, there's an infinite number of points because it's making a straight line. So if I go back and get a new color and we had a straight edge and we drew our line, there could be points all along the way here. Some of them whole numbers, some of them decimal, fractional answers. So they all would work. Alright, so a function, let's review for just a second. A function is a special kind of relation. And a relation is just a set of ordered pairs. And it's a function where each input has exactly one output. Exactly one. One and only one. So every x has one and only one y. So let's check these examples on the back to determine whether or not these relations are a function. So let's check. Does each x have only one y? Looks to me like it does. Every x matches up with one y. What about here where our x and y are in a table? -7 with -12, -4, 2, 3. Every x has one y. Now here's a set, a relation. 2 goes with 1, 3 with -2, 3 with 1. Uh-oh, I said 3 twice. So here's an x where 3 is our x, and it's with -2 and also with 1. So wait a minute, every x can only have one y, so this is not a function. Again, here's another 2. 2 is with 1 and 2 is with -2. So we would say here this is not a function. Why not? Because each x has not exactly 1, more than 1 y. So even if you only had one x that had more than one y, that would make it not a function. So that's what we're going to be checking for. All right, a discrete function, we can talk more about this later, but for now I want you to know that a discrete function is not continuous. All right, it's not, let's say, non-connected points. So if a function is discrete, they're not connected, the points, non-connected points. Continuous function, everything is connected. So that means it'll be a line or a curve to be a continuous function. Okay, we'll talk more about those later on, a lot after Christmas. All right, let's do a word problem. There are 3 lunch periods at school. During the first period, 120 students eat. During the second period, 200 students eat. During the third period, 100 students eat. Whew, okay. So 3 periods. The first period, there's 120. So if we made a table, this is what it could look like. We can do it vertically or horizontally. So the first period, there were 100 students, or excuse me, there were 120 students. Second period, there were 200 students. Third period, there were 100 students. Determine the domain and the range. Well, that's easy. The domain are your x values, 1, 2, and 3. Your range is your set of y values. We like to do the range from least to greatest, please. So that'll be 100, which was the last term. Notice how they don't necessarily go in the order that the domain was in. We're going to always go in numerical order when you're listing your domain and your range. All right. Is this relation a function? Yes, because each x has one and only one y. Is it discrete or continuous? Well, because we jumped around, we went 1 to 120, then 2 to 200, and then 3 went back down to 100. It's not going to be a straight line, and it's not going to be a curve. So if it jumps around a lot, we call that discrete. It's not continuous. If you have a graph, there's a very easy way to check to see whether or not the relation is a function. It's called the vertical line test, and I'm pretty sure you did this last year, so I'm going to move very quickly. If you draw a vertical line, if it only touches the graph at one point, and you might want to check it in more than one place, if it only touches it at one point, then it is a function. So I'm going to let you check and do a vertical line test on all of these relations and tell me yes or no, are they a function? I'm going to leave that for you to finish up with also this last example problem. Determine whether this equation represents a function. After you solve for your x and y, you might find it easy to graph, and the graph might tell you right off whether or not it's a function. So I'm out of time. I'm going to leave this for you to practice on your own. I hope that you have a wonderful, marvelous, fabulous day. Thanks.